Welcome to the book launch, The Living Labyrinth, written by Tim Poston and Ian Stewart. We are from the Bangalore Sci-fi Club, and we are accompanying him on his book launch. So please take it away, Tim.
Well, thank you very much. I'll try to describe how hard science fiction in general gets written. I'll illustrate it with this book. So it's written like any novel, of course. You've got characters and characterization. There are tricks that help, like create the backstory of the individual so that you know them really well when you're writing a novel. But those are general tricks of writing a novel. What I want to talk about is the extra that is hard SF. In fact, I'll describe how one hard SF got written. This one, which we're launching today. And rather wonderful quote from Stephen Baxter. And I imagine everybody in the room knows Stephen Baxter. Anybody that is a science fiction fan knows him. And he says, classic science fiction, a startling and original premise, a character-driven plot exploring that premise with great imagination and ingenuity, recalls Niven at his best, and Niven is a greater name than Baxter, with better science. I mean, I was glowing for a day after he sent us that. So that does give at least proof that this is a fair sample of science fiction, and specifically of hard science fiction. So let's see the processes, or some of the processes that got it written. So, that premise. Now I'm not going to tell you what that premise is because you haven't read it yet, and that's spoilers. I'll just tell you more or less what's in the blurb. But consider a less startling premise, less original. I could name several books that use it, but still a lot of life left in it. I want to write a book about matter duplicators. Lovely books have been written. They copy everything. They can even copy people. You just put something in and you get a copy. This has all kinds of implications. Like, no more mass production. That's the iPhone production facility. You make one iPhone and duplicate it. Everything is changed. Can a company pick its star employees and just duplicate those? Far the rest. Suppose your wife is copied. Who is the wife?
Or is it polygamy?
Well, exactly. You have a lot of fascinating questions. And do you duplicate wives or husbands or whatever? And is it adultery? Supposing we have a culture that says adultery, is it adultery to be in bed with both copies of your wife or your husband? Very interesting questions. We didn't write that book, but there are very interesting questions. Some things can't be copied, like a house, because you maybe copy the house, but you don't copy the land. Some things can't be copied. Who owns it? Which of those copied wives if it's split up? most property becomes intellectual property. Not all property, but most is the right to copy something. Fascinating to explore those questions. But hard science fiction, it demands consistency in your scientific, engineering, technological universe. And matter duplicators. If your science can do that in this setup, then it has really mastered matter in fantastic detail. That's okay as a premise, but if the new physics can do that, it can completely control E equals mc squared. The matter energy equivalence is just basic. So it's ABC of that kind of thing. So you have access to almost unlimited energy. And that means that your story has to allow for planet busters, near light speed drives, because you just keep pushing. You don't even have to break relativity, general relativity, special relativity. You just keep turning the matter that you find in interstellar space into energy.
Into fuel.
And keep using that energy to squirt it at the back. Simple in principle, elaborate engineering in practice. And very liable to blow up. And for that matter, synthetic planets, all sorts of things. Which would be great as a book. But it would make it rather difficult to explore those questions like mass production, copying of employees and so on, things at the human level. Those would get harder. So we wanted to write the equivalent of that story. So how to focus on that limited story rather than the whole technology, the vast things that it brings. So this was our solution. And it's not actually totally an original solution, but it worked very well. Humans get a limited version of the technology. And they can't explore the planet-busting implications. So how do you do that limited version? Colony vessel lands on a planet. The technology drops down drastically because colony vessel can't sustain itself because of the crash. And they discover, for this argument, the duplicators for the actual book, Syntae, and I'm not going to tell you what Syntae are, you've got to read it. Discover them locally, but not from intelligent aliens. Because one thing, writing a human-alien contact story is another thing, another theme, not our particular theme in that book. And how come the aliens don't have planet busters and so on? Same problem. So, they get it from local, unintelligent aliens. Plants. About 2 billion years ago, a combination of mutations gave the local plants Syntae. Evolution led to a huge variety of symbiotic plants, and ways the plants use it, ways the animals use it. The humans land, discover this, and they get synthetic technology for which they have no theory at all, because it doesn't make sense in terms of the physics they know. So they don't develop the big science things. But that technology replaces the original Earth technology and does a lot of equivalent things. It takes some generations to explore the possibilities, and in one book we'd have to have a whole lot of generations, a whole lot of characters, write a saga. We weren't quite confident that the public was ready for a saga on this. So, 2,000 years later, a group of 6 people arrives, they also crash, and they explore the society that has developed on this planet using synthé. And the first view of the planet looks like this. They just label the continents Aleph, Bet, Gimel, Dalet, which is Hebrew alphabet. This is temporary names. And they detect that here and here there are signs of the crash. One of those places will be a beacon that they can call for rescue with, but they can't tell which one. Now, narrative inevitability says they're going to pick the wrong one. So they do. And so we get to explore a lot of the planet through them, because they've got to get from there. Can't quite see where I'm pointing.
Yes. Below that one.
To the other one. Okay. So, heroes trying to get home. This has been a science fiction trope since at least the Odyssey 2,700 years ago. But how did they get there? They didn't get there at sublight speed. Even the nearest planet, the nearest star, 4 light years away, that's a good number of years of actual travel and plausible, wider variety of planets. It would take lifetimes. Okay, other good stories, but they wouldn't be trying to get home because there would be no time, their home would have gone by the time they were back. We've got to have faster than light travel. The trouble is scientific conscience. Because most of the gimmicks in science fiction have faster than light drives. They ignore the fact that general relativity does not allow simultaneity. Simultaneity cannot be defined. So a jump from here to here at the same time is something that leads to terrible paradoxes. And the problem there is that I wrote a book on special relativity and general relativity 40 years ago. It's still in print, so reasonably nice book. And so I knew, we couldn't have simply simultaneous jumps. So what we have is a field increasing everywhere, and you can jump between places of equal level of that K field, Karma Bhumi field. And that is increasing no matter who measures it, although increasing at a different rate. And you can only jump between points where it's equal level. Okay, this is entirely fictitious but not paradoxical. But it increases faster according to local measurements where there's more matter, where the matter is denser. So here is a place where the matter is very dense. So the levels are closely spaced. In that more distant planet, small star, isolated, it increases slower. So it's getting out of sync. Now if it gets enough out of sync, you have the possibility of jumping from a place here to a place there, or from here to a place in its past. Eventually, you get to a place sufficiently in its past that they can send a light signal that arrived in that past. And you got time travel paradoxes again. Okay, well, time travel is great fun as a thing to write, but it's another thing. So nature doesn't like time travel. There's a lot of different evidence for that in a lot of theories. Nature doesn't like that. Nature really doesn't like that. So you get a simultaneity quake. So what you're seeing there coming slowly up is lines of equal place. You can jump between anywhere on the line. And if I can stand, because I want to point somewhere here. All these points, all these times, correspond to the same time here. So, from the point of view of people here, that planet simply disappears for all that space of time. It can't be reached. From the point of view of here, they don't notice, if they don't have this kind of star travel, they don't notice anything happening locally. But suddenly, this place has jumped years ahead. So all over the galaxy we have these simultaneity quakes. Makes life quite complicated. It makes a rigid galactic empire kind of story completely impossible, because you can't have central control of places that keep disappearing on you. Of 2 weeks or 200 years or something. So it implies things for the structure of the place. So, but in the Living Labyrinth, it's really background. The sequel has rather more of it, and very important things happening with Synquates, later stage. But in this book, they're just there. So that's how the Starfolk got there. And they see this from orbit, which is very mysterious. There are people all over the place, but there's no sign how they got from one continent to another. There's no ships, there's no planes. It turns out that the difference between shallow places of the ocean and deep places is really important for the history. So we had to work out the marine geology. This is what I'm saying, we work out background in a way that, for instance, for a general novel, you take ordinary human history or ordinary human society, you can take things as given. You can take the railway timetables from British Railways. But you can't do that if you're making it all up. You've got to check for consistency. So we had to work out the marine geology, which looks like this. So not just the continents, but that is what the whole planet looks like if you see through water. And for the plot, we needed a narrow abyss, really deep water, between shallow places. The background, actually, not events in the book, but needed. So we needed an abyss there. That's